Have you ever really stopped to think about how we see anything at all? I mean, really think about it. It's all thanks to this incredible, invisible messenger that's working all the time, delivering reality right to our eyes. Today, we're going to pull back the curtain and explore the secrets of this messenger, light. Seriously, just for a second, how is it that you're seeing everything around you right now? The colors, the shapes, the movement. What is the invisible bridge that connects the entire world out there with your eyes and then your brain? Well, the answer, of course, is light. You can think of it as a form of pure energy that shoots out from a source in perfectly straight lines. These lines, or rays, are like the universe's own high-speed delivery service, bringing the entire visual world to you in an instant. Okay, so if light is our messenger, what do we know about it? What makes it tick? Let's get into its most fundamental properties. First off, light is fast. No, I mean, it's unbelievably, mind-bogglingly fast. In a vacuum, it travels at almost 300 million meters per second. To give you some perspective, if you could move that fast, you could circle the entire planet more than 7 times in a single second. It's the ultimate speed limit of the universe. Nothing's faster. So then, how do we actually see stuff? Well, it's actually pretty simple. An object becomes visible in one of two ways. Either it's a source, making its own light, like the sun or a light bulb, or it's a reflector, just bouncing light from a source into our eyes. Kind of like how the moon doesn't make its own light, it just reflects the sun's. And that whole idea of bouncing light, it is absolutely crucial. It's so important, in fact, that it follows a very simple, very predictable rule. So let's dive into the world of reflection, or as I like to call it, the Great Bounce. So this bouncing of light is what we call reflection. It's simply what happens when a ray of light hits a surface and bounces off. It's the magic behind why you can see your own face in a calm lake or see that glimmer on a polished car. And here's the beautiful part. All reflection, whether it's off a mirror or the surface of a star, follows one elegant rule. We call it the law of reflection. And all it says is that the angle the light comes in at is the exact same angle it bounces off at, every single time. It's a perfect, predictable dance. Now, to really get this, we just need 3 simple terms. The incident ray, that's the light coming in. The reflected ray, that's the one bouncing off. Easy enough, right? And the normal, that's just an imaginary line we draw straight up from the surface at a 90-degree angle. We measure the angles of both rays from that normal line. So have you ever wondered why you can see your reflection in a mirror but not on a piece of paper? It's all about the surface. A super smooth surface, like a mirror, reflects all the light rays in one single organized direction. That's what creates a clear image. But a rough surface, like paper, scatters the light in a million different directions. We call that diffuse reflection, and it's why you can see the paper itself but not your reflection in it. But bouncing is only half the story. Light has another, even weirder trick up its sleeve. You see, sometimes instead of bouncing off something, it goes right through it and takes a detour. You've definitely seen this, right? You put a straw or a spoon in a glass of water, and it looks like it's broken right at the surface. It's a classic optical illusion, but it's not just your mind playing tricks on you. It's a real physical thing that's happening. This bending of light is called refraction, and it happens anytime light passes from one transparent material, what scientists call a medium, into another. A medium is just anything light can travel through, like air or water or glass. So why on earth does it bend? Well, it all comes down to a change in speed. Imagine you're pushing a lawnmower across your driveway and onto the lawn. The second that first wheel hits the thick grass, it slows down, right? But the other wheel is still on the concrete going full speed. That difference in speed forces the whole lawnmower to turn. That is exactly what happens to a ray of light. And you can see it right here. Light travels at different speeds through different materials. Look how the bar drops. It's cruising along super fast in the air. Then it hits the water and slows down. And then it goes through something dense like glass, and it slows down even more. And every single time light changes its speed, it also changes its direction. It refracts. All right, so we've seen how light can bounce, and we've seen how it can bend. These 2 simple ideas, reflection and refraction, are way more than just fun optical illusions. They are the fundamental building blocks for some of the most amazing technologies and natural wonders in our world. Let's just break it down. That simple rule of reflection, it gives us mirrors. The predictable bending of refraction, That gives us lenses, the things that can magnify tiny worlds or correct our own vision. And when you get both happening at once, light bouncing and bending inside millions of tiny raindrops, you get one of the most beautiful sights in nature, a rainbow. And once we figured out these rules, we learned how to master them. Think about it. Eyeglasses, telescopes that see to the edge of the universe, microscopes that see inside a cell, cameras, the fiber optic cables that power the internet, projectors. All of it is possible because we understand how light works. So here's the big takeaway. By understanding these simple rules, how light bounces and how it bends, we've literally learned how to shape it to our will. We can control it. And because of that, we can see everything from the smallest atom to the most distant galaxy. We're not just looking at the universe anymore, we are actively exploring it. So we've cracked the code on light, this invisible force that literally shapes our entire reality. And it just makes you wonder, doesn't it? What other hidden forces are all around us, just waiting for us to figure them out? What other secrets will we unlock when we finally learn to see the unseen?